Okay, let's get it. I fixed my ant problem. I'm waiting on the landlord to spray or something like that, but I just should have done this earlier. I just put blue tape up in the corner and it's completely flush, so ants can't get through. I was worried at first about it attracting more, but no, we're good. I killed like 2 or 3 earlier again. I was like, okay, dude, I have to do something. I did not sign up for a lease to Grounded. Okay. Okay. It makes sense that we prefer subscripting when we're starting from the first index of the array, the 0 index. Because otherwise, it could be weird. I'm going to make an example where we have a C-style array, and then I set a pointer to a specific element that's not the 0th element, and then I index it with 0, I subscript it with 0, and it's going to access it as it is, not the first thing in the element, which might be, it's not counterintuitive, but it might be unexpected. Oops. Okay. So we have a C-style array of constant integers, specifically 3 of them, 3 constant integers. I've created a pointer to a constant integer so I can have it point to one of these elements, and I've chosen the third element, the 2 element. And now I'm actually, instead of dereferencing it, I'm just going to do numpy 0. Is 0 implied? No, it's not. Okay, so you have to subscript it with a specific, with an expression inside. Makes sense? Okay. So now we're going to get 3 here. And you might see, oh, we're getting, I don't see this. I only see this part here. And you think, oh shit, okay, so we're accessing the first element of an array. But instead, we're subscripting a pointer, and it's whatever the pointer is pointing to, not the first element of whatever the pointer is pointing to. Okay. Excuse me. Negative indices. Oh yeah, true. I think I could do this way too. I think is this -1 and this is -2? If this is 0, -1, -2, so it's -1, -2, -3, which would be 0. What happens here? It's out of range. Do we care? And it returned, oh shit, this code. Okay, so it's actually fully out of range. It's not. Interesting. What about -1? Same thing? Oops. But then 0. Okay, so negative actually doesn't work. Negative is regular pointer arithmetic, where it subtracts 1 from the first index and it's actually going before. It's not negative like an unsigned, where there's some sort of wraparound or wraparound with the index. There's no accessing the last one with a negative. can be either unsigned or signed. It's possible to index it with a negative subscript. I mean, we already saw this earlier with using negatives. Yeah, we can get the previous object, sure. Because it's the same as, let's see, so we have this array, the C-style array of constant integers. I pointer to one of them, specifically it's 6. 0, 1, 2, 3. And we're outputting it to get 6. And then we're also outputting it to get 6 again. And then we're outputting the address it's holding -1 to get the previous object. Dereferencing that, or dereferencing it with -1 to get the previous thing. It doesn't even mean that it's in the array. If we had 0 and did -1, well, there it goes. If this pointer was pointing to the 0 element. I already did this with characters to show it earlier. Iterate through a C-style array without explicit indexing. Meaning, we're actually just incrementing the pointer, huh? And so the end is the first object plus however many the total size is. And so if we're starting at the 0, and the size is 7, the biggest index we can use is 6. Makes sense. It's because we're looking at the 0th element, and then we're looking 7 to the side, and that's how many elements there are. So if we're looking at the 0th, and there are 3 total, 0, 1, and 2, but the size is 3, and we say, okay, we're looking here, 1, 2, 3, we're actually looking at the next element after. So we go until begin, or until the end. I guess just go until the end, basically. And so the point is we're incrementing begin, so we use begin, increment it to step at 1 towards end, use it again, and once it steps again after you've used the last one, won't work because begin is pointing to whatever the end is pointing to. Oops, sorry. Address, not dereference. Or well, the point is it's decaying, so not the address of a pointer. We'll just say it points to nums because nums decays there, and then initialize this guy to be nums plus standard size nums. So there's no for nothing, while begin isn't equal to, oops, sorry, this is a redefinition. While it isn't end, increment do something, and then increment begin. So we start at the 0 and then the 1 and then the 2, or well, the 0, the 1, the 2, the 3. But we've added 4 to it, so it's going to go until end is pointing to whatever the next element is after this. Which is probably undefined. And we'll just say what if we did that? Oh, interesting. Oh, and this is while begin is less than end. Because begin is pointing to an address that's earlier. What if we say begin is less than or equal to? It'll print that undefined one at the end, right? Yeah, nice. Cool. Because it prints whatever's after that piece of memory, which we haven't allocated. Or we haven't created an object at it at least. Yeah, we don't want to do less than or equal to, because then we're going to be printing that undefined element or that undefined object. Or at least printing the object would yield undefined behavior. Because we don't know what's at the object. Start a traversal at the element pointed to by begin, which is the 0 because it decays to a point of constants. Begin isn't equal to end, so we're not past the loop yet. Yep, we could dereference begin to get the value there. Or we could do a 0 subscript, but that'd be weird. Increment begin to set begin to whatever the next element is, or to the next element, or the next object, rather. Which is still within the array, because the array is a sequence of objects. Because it's a container. Heard a plane. Yep, and it will continue once we've completed the loop. Or once we've printed everything in the array. Because end is set to be the object after the array. And we continue until it equals that. Or rather, while it doesn't equal that. Yeah, true, because otherwise you'd have to do array plus standard size minus 1, and then you could say, oh, hey, go while we're less than or equal to. Or just say go while we're less than the whole size. Well, yeah, because if we're one past the element that's already one past, then we're going to print the element. We're going to print at least one element that that abounds. We're going to actually do something with it. If we're going while we're less than the second last element, not the element that's one past, but two past, the two past element. Oh yeah, because standard size tells us the size of whatever it is. So if we pass it first, it decays. It goes down to the size of one, well, not even the size of one element, but the size of an address. And then we get the size instead of getting the size of the entire object. That's quick. Meaning that if we're gonna do a loop with the array, I mean, I guess we could have a print array function that has an overload so that if it takes a C style array, it does this, sets 2 pointers, and goes until we complete the array, versus another one that takes a non-decayed. And that would be, how would that one work? I mean, I guess you just make 2, right? And then, well, let's see. I can't specify this. Oh, I would have to specify a reference, I think. I don't know how to do that yet. Like, we could have one that does the C style that's decayed, and then we could have another one that does standard array, standard vector. Turn the fan on. It's getting too cold. I'm starting to get tired. Okay. You know what? We just take one C style? Yeah, I think that works. So we could say, what's an example? Like print targets. Let's do string view. Oh, we could actually. What if we did a template to accept multiple types of C styles? Okay, so we have different possible targets. And what we do here is we create a pointer. We do 2 pointers. A pointer to the array, and then which is the first element, and then we could have one that points to the first element, or we could initialize it with the array itself. And then we have end that points to it plus the standard size, which means we need algorithm, apparently. So we're going to create a const t pointer called begin, and it's initialized with array, and a const t reference, or it's const t pointer end, and it's initialized with array plus standard size of the array. And then we say for, there's no definition, while begin is not equal to, or I'll just say while begin is less than end. Right? And then increment begin. So we'll say oops. I don't want this anymore. Tired of this wimpy stuff. Hold. Hold. Oh, here's the problem. It's doing it for a decayed guy. So we'd have to pass it via reference, right? Right? Oh, or you could just pass it the begin and the end, huh? And then what if we did it again here? Isn't it twice? Maybe not. Hold. Okay, it's actually maybe okay. What if we just did this? Auto X is targets, targets, and then auto Y is targets, targets, plus, oops, sorry, plus standard size, targets, targets. And instead, what if this is, what if we take, oh, a, what if we say a const t pointer begin, const t pointer end? Excuse me. Oh, well, we don't need these anymore. And now we pass in X and Y. Works. Interesting. Okay. And here the C style is created, the begin and end are created, they're passed into the function. So we pass in the start and pass in the end, and we go while we're less than the end or while we're not equal to the end. I think less than makes more sense than not equal to. But it's cool to show it though. Yeah, there's no decay, so we can actually use, well, there's no standard size there. Standard size is used here. Just say pass the 2 pointers for a function and boom, done. Gotcha. Range-based for loops over C-style arrays are implemented using pointer arithmetic. So we could have a C-style array of constant integers. We could say auto E for this array, print each element. You could remove 2 lines here. It's the point that a range-based for loop will. Gotcha. So a range-based for loop, when you use it, somehow, I don't know if it's a macro or what, but somehow it gets substituted with create a begin pointer for the beginning of the array, create an end pointer for the end of the array, and loop through while those two aren't equal. Oh, so in a for loop, begin was created, begin was created, end was created, and then while begin and end aren't equal, and then begin. So you could create them both there. Like, couldn't we do that? Seems like that's fine. And while begin is less than end, sure. Oh wait, hold. While begin is or not equal to end, increment begin, and then yeah, makes sense. I could see that. But now since here we have this range initializer, I'm not sure what it's for. And it's auto reference. I don't know what that is. Some sort of R value shit? I don't know. And so these were taken out from the for loop. They've been taken out. To have initialized the sequence or range to iterate. Meaning maybe we are iterating over a particular part of a loop? I'm not really sure. I don't know. And the point is what? So we can use that value? I mean, we can already dereference it, but I'm not sure what the extra value of that is. Maybe writing it will help me find out. So you can do it either way. Interesting. These could be the same too. Hold. Hold. Oh, well. Hold. There we go. Because it's dereference, that's the value it's holding, not another pointer. Same shit as we're using E instead of that. Why? Don't know. Why is this the same as this? Because if we dereference a pointer, we get the value at the address the pointer is. We get the value at the address the pointer holds. With pointer arithmetic, subscripting is the same as getting the value at the address the pointer holds plus the subscript value, which in this case is 0, which is the value that it already holds, so there's no change. Cool. Ants have yet to break through. One month of learning left, I gotta hurry up. And I might honestly just continue the learning too. Yep, sure. Well, I mean, we could do that for any array, really, but C-style is the built-in one, sure. Makes sense, yep. Yep. Yep, sure. A character for a non-const C style string. Hmm. Yeah, agree. Yep. C style strings decay and points to the first element, probably. Yeah. Hmm. Makes sense. Because literals are character are consts versus the strings that we create might not be. Yep. Yep. Because that was the second answer instead of passing the length every time. So if you create it with string like that, and we output string, and we print it. Hmm. Hmm. Oh, when outputting a C style string, it will continue outputting characters. Interesting. So we don't have to put in a loop or anything. Even though this print function didn't work, we're just calling standard character output with the character. Gotcha. So we could have hmm. Oops. Excuse me. And so it'll automatically do pointer arithmetic, seems like. Makes sense because it'll keep printing. Yeah. Larger than we're ever likely to need? Oh, that's kind of ass. So C-style string of numbers in this case. We're saying, okay, 255 is the max, and that includes one null terminator, so it's 254. That's how many rolls we can do in one character. Hmm. Meaning, so we set the buffer size to be 255, right? And if they're submitting it all at once, then it'll overflow. Does it just, it doesn't automatically ignore the remaining? Makes sense, yeah, because we're saying, hey, we're storing your password here, but if you enter a password so long, and we're extracting your password, it'll extract your password to the next place in memory. Hmm. Hmm. Is this different than standard get line? Oh wait, whoops. Wait, what? Iterator. Wait, no. So where are we extracting and how much are we extracting versus oh, it's totally different. Take an iStream. Right? Hold. So we're passing the string we're extracting to, the object that we're extracting it to, and then the left string that we're omitting maybe, versus the place that we're extracting the string and then the count. Okay, so totally different things. Character input.getLine versus standard getLine, totally different. So we could do yeah, but don't we have to say how large it's going to be though. Called. Is he passing in the size? He is? Oh, we can't exactly extract if it's const, huh? Oh, iterator has standard size now? Okay. Same error here. Okay. I don't know about this character input.getLine shit. And it will extract 2 roles, and it will extract up to 254 characters. Because that's how many characters are actually in the array here. And so we're saying put a character, another character, another character, another character, and it can extract all of them up to a maximum. And the remaining ones will be discarded. Okay. We need to say, hey, here's the range you're allowed to extract characters to, because any further, we don't have room. Choose a string. Okay, because a standard string is a standard vector. Seems like. Well, because we can only access one element at a time. I think so. We can't initialize the entire thing at once later. Maybe we could loop through it and assign each one to be the character you've passed. So we say, hey, this index gets this gets this gets this, etc. Hmm. Because the size of the array could be larger than its length. Like its capacity is longer than its length, basically. I mean, really, I think the length is actually. Hmm. I don't know if they're value initialized or what. I mean, oh, we get a bunch of empties, huh? Okay, so they are zeroed out. String length, C string, Sterling. Hmm. Interesting. I wonder if it goes until it sees an empty character. Oh, or I guess it goes until the null terminator, huh? So when we do this, yeah, see, the null terminator prints the same way as the rest. I need more music to stay up. Other C-style string manipulating functions. Sterling, so copy, string. Stern. String? I don't know. Who is this again? God damn. String copy. So we could say string copy this and this. And append string cat, string concatenate, string cat. Stir compare? Oh, okay. Okay, avoid them. Nice. What if they, can we, well, if we evaluate them, yeah, this is, yeah, probably, right? I'm gonna make two name C-style strings and I'm gonna compare them. And they're both gonna start with E, but their second character is gonna differ. One's gonna be EH and one's gonna be EA. And I'm wondering if they're gonna be equal. Okay, music is the way to keep me awake for sure. Oh, I don't know where it's from then. Is it X utility? No, I don't know where it lives. All right, whatever. What do you mean? Oh, it's an iOS. Here it comes. It's deprecated for array types, huh? Because, basically it doesn't work for C-style arrays, huh? Okay, so no, what if we did... Still hold, or name now, it's just wrong, named wrong. Oops. So it's cool, just not C-style array types. Not equal. That's because these are these kinds of arrays. It makes sense that it wouldn't work for C styles because it's going to decay both, and we're only going to be comparing the first character of both, which would be E. So EH and EH and EA would be equal or equivalent. Avoid non-const C style strings, huh? Prone to overruns because we're going to be updating them or like looping through them to change stuff, which means we could be changing later pieces of memory. Which is even more dangerous than maybe the undefined behavior of reading extra memory. Yeah, here's the extra piece from the actual overriding extra memory instead of just reading it. Okay. Avoid C-style string objects in favor of standard string. Okay. Write a function to print a C-style string character by character. Use a pointer and pointer arithmetic. Okay. That's it. Okay. We need to be able to print, so we need standard character output. What does he want? I'm just gonna do begin and end, right? Yeah, sure. I could do that. So we could just say, do we want a template? We could do auto too. I'll do this. The const t pointer begin, const t pointer end. For nothing while begin is less than end. Increment begin and do. At the end I wanna, well, okay, sure, I guess I'll finish this part. I kinda wanna first do. There we go. Output, begin. Okay. And now we get a big const expression array of characters called name, and it's my name. I'm gonna do print array name. Hold. Why is it not happy? Oh, duh, because we could do two of these. Oh, we could do name and name. I want another thing first. I need algorithm because we need standard size. And I'm gonna do name plus standard size name. Hold. What are you complaining about? Hold. Oh. The actual call piece. Cool. Now how about and next line, good. Can't make this guy const expression because oops. These guys are runtime only. So oops. What else? We could do it the other way too. Yeah, but we'd need the character length. That'd be stupid. Loop through this many characters. Fuck that. Function to print a C-style string character by character. Linear arithmetic, yes. A main function that tests, yes, cool. Print C string, boom. Oh, we could also do that too if that's the null terminator. Okay, and now we could just say I mean, you could do a couple things. You could say for no definitions while this guy is not inline character, or sorry, null terminator, increment string and output string. You could do that. Oh, and then also okay. We could also do right? Uh-oh. Duh, didn't increment it. Whoopsie. What else? You could do you'd say while it's not the inline character, or the what's it called? It's better. Okay, I think that's all you can do. Yeah, you could do this either way. Repeat. Oh, print the string backwards. Okay. Fun. Let's do excuse me. Start backwards, huh? So we have to get the last element. Excuse me. Alright, why did I say excuse me? I popped my fucking legs. My hip. Alright, printing it backwards. Print the string backwards. So we need to start by getting the last guy. Or I could receive it as 2 pointers. I think I have to do that before the decay, right? So let's just do that. So we'll say, excuse me. Wait, hold. Could do that -1. We could say while string end is greater than or equal to string begin. We're going to start by decrementing it, because right now it's set to be 1 passed. Okay, and then we'll hold. Because in this case, it's going to be, eventually it's going to be equal to it, so we don't want to do it this way, I don't think. We could say, we could say while it's not equal to, or we could say while it's greater than. All right? If it's greater than, then we'll decrement it to make it equal and then go, and then it won't be greater than at some point, and then we could say, okay, I think this works. Told you. Okay, so we could start at 1 passed, and we say, okay, well, this guy is definitely greater than the beginning. Okay, so here's end, here's begin, here's first element, last element, this is the end. So we step back by 1 to get into the string, and then we print it. And then we check, hey, are we still greater than this guy? Are there still more characters left to print? Yes? Step, print, step, print, step, print. Or really, it's step, print, check, step, print, check, step, print, check, step, print, check. Or it's really check, don't step. Done. We could do, and we have to start at the end, because if we just pass it the decay, still antless. If we pass it the decayed pointer, we could set a pointer equal to it. We could step through it to find the end and then step back down, but that just seems stupid. Let's do it this way though. Let's say we don't pass it begin and end. We literally just pass it name. Okay, so what are we doing? We need to find last character. So I think we just say for, I think we loop through it, huh? So don't create anything. We could say, could create another string. So we could say const character pointer will say string begin. Or we could say begin and it's initialized with string. Okay. And then we'll say we would say while string is not the endline character or the null terminator, increment string. And once it is equal, or we could say yeah, but we need to find how many that is. So I guess we say I almost want to do a while loop instead. I'm gonna just test. Say while true. So we could create the null. Oh my god, that's so much louder. Very nice. And so what do we want to do? We want to step through and check. So we could say if begin is pointing to the inline, the null terminator, then set end to be begin. And if it is, we also need to break. What's the issue here? Hold. Oh, sorry. This is string. We can't exactly. Well, we'll hold. What was happening here? I don't know what you're talking about. This should be string now. If need to save string beginning, save string end, not none yet, find end of string. If it is, boom, otherwise increment string. And then, okay, this is like a million times worse than what I did initially. But you have to loop up to find the end, and then print back. And then for define nothing. And we'll say while end is greater than or equal to begin. We can decrement end, output end, and then is that it? I don't know if we need any more. Oh, oops, sorry. Hey, what? Hold. If int or well. Oh, these n should not be const. Oh, well, we can't assign it. This guy needs to be assigned an address. Oh, but it also needs to be, well, hold. What are you bitching about? Hold. Oh, it hasn't been decayed yet? So what? Do I actually need to put const character string? Really, even then? Hold. Wow, come on. Right? Don't I need to get the address of 0 then? I think I'm overcooking this. Why not? Can't convert a pointer from const to non-const, huh? Oh, well, I guess we're just incrementing. How are we able to increment string if it's Oh, because it's a pointer, it's not a const pointer. Okay, I don't think we need n then. Boom. So what was the issue there with using end? The point is that, well, hold. So this is fine. We pass him, he's decayed, he's here. But I can't assign an end. No? Hold. Right? Because we can't drop the constness? Yeah. So we have to just use the... This is a pointer to const and it can be changed. But I can't pass the address of it to something that can modify it. Interesting. Okay. You can do it either way then, I think. I think that's it. What? Bro, what is your syntax here? Who wrote this? Was this not Alex? It was Alex. Alex was tripping back in May. That was a while ago. You're tripping, brother. So, a pointer to a const character. And so this is the beginning. So we need to store the beginning. And then we say, while it's not pointing at the end character, increment it. So step up until we find it. And then step back down. So you could do it with a for loop in one, or you could do while. That's fine too. Let me make this better. Oh, so we could say beginning, so const character pointer, call begin, and it's initialized with string. And while string is not the null terminator, increment string, and then once it is, step string up until it hits the end. And while it's greater than begin, alright, I'm done. Hold on. Hold. Oh, oops. While it's not holding that, the fuck is happening? Hold. Oh yeah, true. We have to decrement it. Otherwise, just we're going to be printing it forever. Wait, what? Hold. Oh, we also need to print this too. Because the last thing we're doing is printing the start character, so we need to go while we equal the start character. Oh, you could also do... Are you sure? Oh. So you could say while string is greater than or equal to begin. So we say while string, and then decrement it, is greater than begin. Boom. This isn't clear. I don't like this. No, what? Yeah, I don't like that. Yeah, there's a fucking reason why. Okay. Alright, we're done for now. More in 30 minutes.